Hello and welcome to this Bioprocess International Ask the Expert webcast. I'm your host, Leah Rosen, the online editor for Bioprocess International, and before we get started, I have just a couple of notes. This webcast is being recorded and will be made available for replay in the multimedia section of our website. We've muted the audio lines, but we welcome you to type in your questions for our speaker in the chat window on your screen. After your presentation, we will begin the question and answer portion because this is, after all, Ask the Expert, and I will ask our speaker your questions from the chat window. Your questions in the chat window will only be visible to myself and our speaker. So thank you for joining us today. It is now my pleasure to introduce our speaker, Harris Grevelis from Repligen.
Hi, good morning, everyone, and thank you for joining us on today's webinar, co-hosted by SAFC and Repligen. My name is Harris Grevelis, and I am a product manager at Repligen, supporting our upstream products, including LONG R3 IGF-I, which you'll hear me commonly referred to as LONG R3. And today, I will focus on the topic of optimizing cell culture productivity with the use of recombinant protein supplements, specifically insulin and LONG R3, that can be incorporated into your cell culture media. Plan today is to walk you through some perspectives on the evolution of approaches to optimizing cell culture media, compare the biochemical characteristics of insulin and LONG R3, and then we will transition to our data sets, which compare the effective media supplements on cell culture performance, and then we're going to close with some conclusions. So to get started, this graphic depicts the evolution of cell culture media and the supplements that have been used in the industry. Supplements and growth factors are critical ingredients used to improve cell growth, viability, and productivity to ultimately achieve better and consistent product quality. As we all know, serum has historically been the most common cell culture media additive. It is a very effective supplement but poses contamination, regulatory, supply chain, consistency, and cost challenges. As the industry further adopts chemically defined media and looks to move away from the use of serum, the need for high-quality, defined cell culture media supplements has become more critical. As a result, the industry moved towards animal-free components such as plant hydrolysates. Ultimately, these also introduce relatively undefined components and commonly present with lot-to-lot variability. Taking this a step further, media companies have also now developed chemically defined protein-free media formulations. While these eliminate concerns associated with contamination in animal-derived products, they often deliver subpar productivity and viable cell density as the media is not rich enough to support cell growth. Recombinant proteins such as insulin and LONG R3 IGF-I provide multiple benefits as cell culture media components. Insulin and LONG R3 supplementation represents the best of both worlds. The supplements are defined, highly pure recombinant proteins. They're animal origin free, have secure supply chains, consistent GMP quality, and allow the end user to ultimately have a completely defined cell culture media formulation. So, moving on, let's further understand the mechanism and benefits of insulin and LONG R3. It's well established that insulin is an effective serum-free media supplement. The structure of insulin and IGF-I are very similar, as you can see here. Thus, it's commonly believed that the mitogenic effect provided by insulin in culture is actually mediated through the IGF-I receptor and not the insulin receptor. Because of its relatively lower affinity for the IGF-1R, insulin supplementation requires high, non-physiological concentrations, typically between 2 to 10 milligrams per liter of media. LONG R3 is an analog of IGF-I with a 13 amino acid N-terminal extension that reduces its affinity for IGF binding proteins by more than 100 times. Because LONG R3 is the correct biochemical ligand for the IGF-I receptor, and it's not sequestered by IGF binding proteins, LONG R3 can be formulated at concentrations of only 10 to 100 micrograms per liter, while still providing a benefit to viable cell densities and cell culture productivity. This low formulation concentration results in 100 to 1,000-fold less protein being added to the medium, which reduces the burden on downstream processing. So moving on to some of the data. As an overview, one of one of the most challenging aspects of culturing recombinant cell lines is providing for their diverse nutritional requirements. The media development experts at SAFC have developed a technical approach for designing and optimizing cell culture media for recombinant cell lines. In the first stage, the required performance targets for critical process parameters such as VCD or productivity are defined. Then the performance of each cell line and numerous media configurations is screened. A principal component analysis with multivariate analysis software is then used to identify the critical raw materials of each media formulation. Critical raw material concentrations and combinations are then further optimized using design of experiment analysis, or DOE. Using this approach, SAFC has demonstrated that LONG R3 is an effective media supplement. Recombinant proteins in general are often identified as critical raw materials, and the effective concentration of LONG R3 is unique to each cell line and therefore should be optimized. With that background, we can now transition to some of the experimental data sets investigating the effect of LONG R3 and insulin. In this first slide, the effect of LONG R3 concentration between 0 and 1 milligram per liter on viable cell density of an SAFC chosen cell line was investigated. Data indicates that VCD increases as LONG R3 concentration increases by nearly twofold. However, above an effective concentration of 0.1 mg per liter, the change in or impact to VCD decreases and the curves merge and plateau. With this particular chosen clone, LONG R3 concentrations above 0.1 mg per liter are less effective and impactful to VCD. Thus, LONG R3 can positively impact viable cell density, and the effective minimum concentration needs to be optimized. This next data set looks at the effect of LONG R3 concentration between 0 and 1 mg per liter on the productivity of that same SAFC chosen cell line, expressing IgG. We can see that as LONG R3 concentration increases, the volumetric productivity also increases. With the addition of 1 mg per liter LONG R3, a greater than 33% increase in volumetric productivity was realized, and at a more modest concentration of 0.1 mg per liter, productivity increased 28%. Again, this shows that the required LONG R3 concentration should be optimized depending on the requirements of the cell line that's identified. As described previously, DOE can be used to study the required concentration and interaction between critical cell culture media components. In the next two slides, I will describe and look at some DOE experiments used to optimize concentrations of LONG R3 and insulin. This experiment that you can see here used a different CHO DHFR clone and a two-level factorial design with 11 input factors, with insulin and LONG R3 concentration being the critical inputs and IgG titer being the critical output. As a note, this model was significant and the lack of fit was found to not be significant. Data here was collected using a Forte Bio octet system. The resulting interaction plot shows the impact of LONG R3 concentration with no insulin, as well as the maximum amount of insulin used. With or without insulin, as LONG R3 concentration increased, IgG titer also increased. But maximum productivity was seen with a combination of both insulin and LONG R3. In this experiment shown here, we used the same DOE design and experimental conditions with two different chosen cell lines. Here we look at the same experimental design as the previous slide, but we'll compare two different chosen lines. In these two graphs, insulin concentration remains constant, like we saw in the last slide, but with the chosen 23 cell line on the left, productivity remains the same, regardless of LR3 concentration, when the maximum amount of insulin is added. With the chosen 3A6 clone shown on the right, an increase in productivity was found when LONG R3 concentration was increased. So there was here there was a beneficial interaction of insulin and LONG R3 on the 3A6 line. In conclusion, we've established that multivariate analysis software, followed by DOE, can be used to identify critical raw materials in a media formulation and help determine the optimal concentrations of those components. LONG R3 IGF-I alone, or in combination with insulin, can speed growth as well as increase viable cell density and protein production. LONG R3 allows for less protein supplementation while improving cell culture performance. And finally, LONG R3 with or without insulin should always be tested with any CHO cell line. Even when one clone has no response to LONG R3, another clone of the same line may actually benefit from LONG R3 supplementation. And now here's my opportunity to plug our sample program. You can see here on the right, if you'd like to request a free 5 mg sample of LONG R3 to test it out with any of your own cell lines, you can contact your local SAFC rep, a Repligen sales person, or you can simply just visit repligen.com/LR3sample. Before closing, I'd also like to highlight in detail the partnership between Repligen and SAFC. Repligen manufactures LONG R3 in Sweden according to GMP guidelines, and there are detailed business continuity and disaster recovery plans to always ensure a continuous supply. SAFC is Repligen's exclusive distributor for LONG R3. To ensure the continuity of supply and mitigate supply risk, SAFC and Repligen combined hold finished goods inventory equivalent to 2 years' worth of demand. Together, we provide cGMP manufacturing of a critical cell culture media supplement, ensure consistent product quality, and provide worldwide distribution and drive strong business continuity practices. I'd also like to show this slide right here, showing our references and acknowledge the SAFC group who put this data together. In closing, I just want to thank everyone for taking the time to attend today. If you're intrigued about SAFC's expertise in cell culture media development or are interested in evaluating the impact of the LONG R3 supplement, please feel free to contact me. My email is on this slide. In addition, if you'd like a sample, you can always contact me directly or visit repligen.com/LR3sample. At this time, we're happy to entertain any questions that you may have, and thank you again for your time.
Thank you, Harris. So the first question we have is, does LONG R3 have any positive effect on SP20 cell line growth productivity?
It can, but it totally depends on your specific cell line. This is why it absolutely needs to be tested. In general, we usually see an increase in viable cell density, which of course then results in more product. More cells equals more product. But in some cell lines, we do see an increase in specific productivity as well.
And is there a way to quantitate LR3?
There is. We have, Repligen actually has a LONG R3 ELISA kit, which can be used to measure LONG R3 in your media formulation or at any time during the optimization process.
And what working concentrations of LR3 have been shown to be effective?
So most commonly, we see somewhere between 10 micrograms per liter and 100 micrograms per liter to be most effective. In fact, at anything over 100 micrograms, sometimes we actually even see a decline. So definitely somewhere between 10 and 100 micrograms per liter.
Do you have general process media conditions for CHO cell lines? No,
we do general process media conditions, which is relevant. CHO cell line. We do have some suggestions on how to use LONG R3, how to test it, how to implement it in your media formulation, and then of course the experts at SAFC can also always help with that as well, not just for LONG R3 but media optimization in general.
And can you describe the sampling program?
Absolutely. All you have to do is visit the website, fill in your information, and myself or one of our salespeople will contact you basically just to confirm your address, and then we will ship you a 5 milligram sample.
And what formats and package sizes is LR3 available in?
So LONG R3 comes in a number of different formats. It comes in both a liquid and a powder. The powder is available in both 5 milligram sizes and 50 milligram sizes. The liquid is available as a 5 milliliter liquid or 100 ml liquid, both at 1 mg per liter concentration. 1 mg per ml concentration, I'm sorry.
And we did have a little problem with some audio, so could you explain the interaction between insulin and long R3 on the plot again? I think about slide 11.
Let me see if I can go back here.
12.
So I hope I have the right slide up for you. Basically, what this is showing is that the concentration of insulin stays the same, right? So we're looking at both concentration of insulin at the minimum as well as concentration of insulin at the maximum. As we increase the long R3, we do see an increase in productivity, right? So the titer goes up, and this is as the lines converge. That's how we know that we're seeing an impact on productivity based on long R3 concentration as it rises.
Okay. And can we add the supplements to any standard media?
Yes.
Okay. And are there any milestone agreements to using the product?
Any milestone agreements on using the product? I'm not sure I completely understand that question. I can tell you that long R3 is currently used in a number of commercially available products today. I'm not sure if that answers your question or not.
Okay. They can always follow up. You can always follow up with Harris via email, and he'll be getting the questions that you asked today and be able to get back to you with some more details. And finally, is long R3 delivered in a single bolus addition or repeatedly?
So long R3 is actually usually added to the basal media. It's a growth factor commonly found in the basal media. Because of the long tail on the long R3, it's been known to last longer in culture than either a standard IGF-I or even insulin alone. So it often is not needed to be added with feeds.
And on the slide that we're looking at, what is the concentration range of long R3?
Yeah, so the concentration range is actually going to be proprietary information for SAFC, but we can always follow up with that. If you'd like to get in touch with me, send me an email, connect with me in any way, and we can definitely follow up with you with some suggested concentrations. Yeah.
Okay. Well, again, here is the email, and we will be sending you a follow-up email that will include Harris's contact information so that you can get in touch. Thank you very much, Harris, for your presentation, and thank you all of you for attending this Ask the Expert webcast.
Thank you all very much for attending.